In this tutorial, we'll learn about Dryo, a free online tool used to create diagrams like flowcharts, entity relation diagrams, architecture diagrams, and more. The example we will build is a basic login process, which is something you see in almost every app or website. First, we start with a start shape, which represents the beginning of the process. From there, the user is asked to enter a username and password. This step is important because it is where the system receives input from the user. Next, we move to a decision point labeled correct. This is shown using a shape in Dryo. The system checks whether the username and password are correct or not. If the answer is yes, the user is successfully logged in and taken to the main page, which we can label as the dashboard or home screen. In your example, this is where the user reaches the successful login destination. However, if the answer is no, the system does not allow access. Instead, it shows an error message saying show error and asks the user to try again. After that, the flow returns back to the input step where the user must re-enter their username and password. This creates a loop until the correct credentials are entered. Overall, this simple diagram helps us understand how decision-making works in a flowchart. It clearly shows how a system can either allow access or reject it based on conditions, and how users can retry when something goes wrong. Add arrow to the shape to show the flow between the shapes to the next step, such as enter username and password or the decision point. This architecture diagram represents a scalable web application built on Amazon Web Services, where each service plays a specific role in handling traffic, processing data, and storing information efficiently. The system is designed so that user requests enter through CloudFront, which improves speed and performance by caching and delivering content from edge locations close to the user, reducing latency and improving overall response time. From there, requests move to a load balancer, which distributes traffic across multiple backend servers to ensure no single server is overloaded. This improves reliability, fault tolerance, and scalability, especially when the number of users increases. The load balancer also helps route traffic only to healthy instances, ensuring the system stays available even if one server fails. The application layer runs on multiple EC2 instances, which handle the core business logic such as processing user actions, running APIs, and communicating with other services. These servers can be scaled up or down depending on demand, making the system flexible and cost-efficient. The EC2 instances connect to an RDS database, which securely stores structured data like user accounts, transactions, and application records while ensuring consistency and backups. Finally, S3 is used as a storage layer for static and unstructured data such as images, videos, logs, and backups. It provides highly durable and scalable storage that integrates easily with the rest of the system. Together, these services create a robust cloud architecture that is scalable, secure, and capable of handling large amounts of traffic efficiently. This setup also allows developers to easily maintain and update the application without affecting the entire system, since each component operates independently. In addition, monitoring and security tools can be added to improve visibility, detect issues early, and protect sensitive data across all layers of the architecture. Furthermore, this kind of design supports high availability across multiple availability zones, meaning the application can continue running even if one data center goes down. It also allows horizontal scaling, where new EC2 instances can be added automatically during high traffic periods. Overall, this architecture is commonly used for real-world production systems because it balances performance, scalability, and reliability in a structured and maintainable way. An entity diagram is a way of visually representing how different data objects, entities in a system are connected and structured, usually in a database design. In a typical e-commerce system built in Draw.io, the main entities include users, products, orders, and order items. These entities help define how information flows and how different parts of the system relate to each other. The user's entity represents the people who interact with the system. It is usually the starting point of the model because every action in the system is tied to a user. Each user can perform activities such as browsing products, placing orders, and viewing order history. The product's entity represents the items that are available in the system for users to purchase. These products are stored independently so they can be reused across many different orders. This allows the system to manage inventory and display available items to users efficiently. The order's entity represents a transaction made by a user. It acts as a record that connects a user to a purchase event. Each order groups together what the user is buying at a specific time, making it easier to track purchases and manage order history. The order items entity connects orders and products together, representing the specific products included in each order. Since one order can contain multiple products and each product can appear in many orders, this entity helps manage that relationship. Overall, the entity diagram organizes these components in a structured way to clearly show how data is stored and connected in the system. Entity diagrams are useful during planning and communication stages of development. They allow teams to visualize the system before writing any code, reducing errors and improving collaboration between developers, designers, and stakeholders. As a result, entity diagrams are an essential part of designing any structured data-driven application. Moreover, entity diagrams also help identify potential issues early in the design phase, such as redundant data or missing relationships. By reviewing the structure visually, developers can optimize the database for better performance and avoid unnecessary complexity later in development. This leads to more efficient queries and smoother system behavior under load. Entity diagrams act as a long-term reference for maintaining and updating the system. As new features are added, such as payments, reviews, or shipping details, the existing structure can be extended in a consistent way. You have successfully completed the tutorial for building diagrams using Dryo and understanding how to design basic system flow charts, architecture diagrams, and entity relationship models.